There's a lot that we can learn from using capillary tubes as an analogous system for studying the unsaturated zone. And we're going to keep pushing this analogy a little bit further to reveal another very interesting phenomenon. Let's say that you've got a big tank, 3 capillary tubes in it, 1, 2, and 3, different radii. And you start with this thing completely filled with water. It's totally filled to the top. All the tubes are filled, and then the tank surrounding it's filled. The experiment that we're going to do now is we're going to let water flow out of the tank. We're going to allow this tank to drain. The water level in the tank is going to start dropping. The pressure at the bottom of each of the tubes is going to be dropping as the water level is lowering. And the question is, which tube gets an air bubble in the top first as we're lowering the water here? Well, if you guessed number 1, you are correct. It's the biggest tube, and it's the one that the air will enter in first. And the value of pressure that this tube experiences when air enters into it is known as the air entry pressure. That's the pressure of at the meniscus right there. And the idea here is that as long as the capillary rise in the tube is greater than the depth lowered, no air entry will occur. So I'll write that concept out so that it's clear. As long as the capillary rise is greater than the depth that we lower the water to in the tank, there will be no air entry or drainage. And this explains a whole bunch of things. One, it explains that first part of the characteristic curve that I drew, theta, negative psi, where you don't see a drop with a decrease in pressure here. So that is the air entry pressure. So I was sneaky and I snuck that into the last video. We're explaining its phenomenon and why it happens now. So this explains the first part of the curve, of the water characteristic curve. Where theta is equal to n, even at negative pressures. And of course, it's also, you can kind of think of this open part here is reflecting the water table. The height of the water here is going to determine, of course, the height of the capillary rise in the capillary fringe as well.